All right, here we go. Well, I guess it doesn't have a number. The first one we're doing. All about Josh. What is the complement of the event that he draws a red piece of candy from the bag? What's the complement of that event? Anyone? Olivia. Draws a blue piece. Agree? Agree. Moving on. All right, two events, A and B, are independent. They give you P of A. They give you P of A and B. Okay. What is P of B? What'd you guys get for that one? Any volunteers of answers? Page. 0.8. I agree. Did you guys get 0.8? Questions on that one? Next one. Events A and B are independent. They give you P of A and B is 0.25. Enter possible probabilities for events A and B. I kind of already did this one with you guys. What's the easiest one? 0.5 and 0.5. Good. 0.5. 0.5. Next one. Probabilities for two events A and B are given. What is the probability of A given B? How many of you, be honest, just so I can gauge how well we need to go over this or how thoroughly we need to go over this one, how many of you were very confident in this problem? How many of you are pretty iffy? How many of you didn't raise your hand? Lies! See, that proves my point that nobody wants to vote. All right. Jackson, you were really confident in this one. What'd you get?
Well, the reaction from Jared
makes you nervous now?
Yeah. But I got A equals 135.
That's what I got. Oh, look at how many are confident now. Did you do it mathematically, or did you do it like, this just makes sense to do it this way?
I just did it the way we always do it. We just did 0.4 times A is equal to 0.1.
Okay. Now, here's what I'll ask. Did you see how on the last one it said these are independent? These are independent. Did it say these are independent? No, but did you still get away with it? Yeah. All right. So my point to you is be careful. Be careful. All right. Can I say P of A and B is P of A times P of B? With confidence, can I say that? No, because I didn't know that if they're independent, that's fine. Use it all the time. If they're dependent, then I need to adjust the second part and write what? P of, is it B given A or A given B? Okay. It could be that. Could it also be P of B, P of A given B? It depends on which one happened first, right? So be careful there. Here we go. We know this part is 0.14. Now, here's the problem. I don't know what P of A is, correct? So could I also write this as, in another version, P of A and B is P of B times P of A given B's already happened, right? Because this one we're treating as B treating B as the first event to happen, right? Drawing that ace, whatever it is, and the second one is probably drawing another ace, given that first one was drawn and kept out, right? Either one of those could be correct. Do you agree? Because we don't know which one happened. And based on the numbers they gave us, we can fill in P of A and B is 0.14. We can fill in P of B is 0.4 times P of A given B. And in this scenario, they're asking us for P of A given B. So I would divide 0.14 divided by 0.4. You'll get your answer. Now again, these happen to be independent events. We got away with it. But there's some times where it won't always work out that way. All right, so you have to actually write out the formula and solve for what they're asking for. All right. What was it, 0.35? Francisco asks the students in his high school what pets they have. He studies the event shown. Event S, student has a cat. Event T, student has a dog. Francisco finds the two events are independent. Select all the equations that must be true. I hate these ones. You guys hate the must be true ones?
Yes.
Here's what I hate about it. A couple of reasons. One, you have to test every single one of them, right? And it takes some time. The second thing I hate about it is they don't award partial credit the way I would award partial credit. All right. Sometimes it's like a one or like a 1 pointer, and it's like all or nothing. Like if there's like 4 check boxes that were right, and you don't get all 4 of them right, like they don't give any points. It's just like that's not a good way to test understanding. They didn't ask me though, so whatever. All right. Did you guys have time to get to this one?
Yeah. Yes.
All right. Let's vote. Who says we're looking for which ones are true? Who says the first checkbox is true? Only a couple of you. Vote. Please vote. It is true. It is true. Okay. Now, Tally, go ahead.
I'm kind of confused because out of all the T's, how many are S? Wouldn't that be none? And so the answer would not equal S, it'd just be none.
Ask again, please. Of all the
T's, none of them are S. So wouldn't probability of S given T be 0? And that doesn't equal probability of S?
Francesca asked the students in school what pets they had. It doesn't say that. I guess I'm trying to understand what you're asking. You're saying since there's no overlap between.
Yeah, that makes sense. I'm just good. But I just like, yeah. I mean, that happens. I really shouldn't, you know.
I guess I'm trying to understand what you're asking. Are you saying that like a student who has a cat can't have a dog?
Yeah, because I said independent. So they can't go there.
She's over there.
Yeah.
I wish the mobile was still. Yeah, I know. Well, it is.
Okay.
Yeah, I know.
Here, let's go back to. I see what you're saying. The math teacher in me wants to always go back to a formula. I know it's not like. That's kind of how we have to think about it. Hey guys, please listen. Stop talking. Listen. There's some scenarios they're going to give you where the wording can confuse you, and you're going to be like, could they have a both? Could they have this, that, whatever? And sometimes it's like almost reassuring to have a formula to go back to, just because you can take all the other stuff out of it. And so, what did I say? Anytime you get confused, go back to the rolling a 3, given that you've already flipped ahead, right? What's the probability of rolling a 3 given you've already flipped ahead? That was just the probability of rolling a 3. Yeah, 1 out of 6. Do you agree? Let me say it again. The probability of rolling a 3, given that you've already flipped ahead, it was just the probability of that second event happening. Why? Because I don't roll the die until I've already flipped ahead, right? So isn't it just the probability of the second event happening? And be careful, it's the order matters. What's the second event? Well, I flipped the head first, and what's the probability of rolling a 3 given I've already flipped the head? It's just the probability of rolling a 3, which, yeah, is 1 out of 6. Do you agree? Now, Tally, here's what I'm trying to say. If you go back to that formula, we can insert whatever letters they're trying to get us to do here. Do you agree rolling a 3 and flipping a head are independent? Okay. So is P of S given T, what would go here if they're independent? P of S. This is the definition of independence of a conditional event, right? That's our formula we go back to. Are you with me? Okay. So the math teacher and me, like, as soon as I saw independent, I didn't really even think about the scenario of having cats, dogs, whatever. Like, go to the formula. Now, how about this one? P of S given T equals P of T. Now, how about P of T given S is P of S? What should it be? P of T given S is P of T. Right? Now, what else? For independent events is P of S, what's that symbol again? Or T, is it the multiplication of those events? No. It's and probability is the multiplication of those events. Do you agree? For independent events. No, I'm gonna be completely honest with you. I might need help with the actual results of that study. Like, what do you guys think is the actual independent aspect of that study? Because I think, Tally, you're getting confused about overlap of a person having a cat and a dog. Is that correct?
Yeah, if they're independent, wouldn't they not allow them to have both?
What do you guys think? What's the independent part of it? Is it they're not allowed to have both? Here's the way I would say it, and I guess this is the best approach I can say. The probability of rolling a 3 was not affected at all by flipping it. The flipping of the head had no effect on rolling the 3. Them having a cat had no effect. There's no effect of having a cat because they had a dog. That's the independent nature of it. The more I think about it, I think that's the way I would explain it, is that having a cat had no bearing on whether they also had a dog. And having a dog had no bearing on whether they also had a cat. Those are the independent nature of it. But do you see how once you get caught up in thinking about that, it kind of confuses the math behind it? So I'm glad you brought that up. I think it's a fair question. I think you have to trust the math formula first, and then if you can make sense of it that way, that's great. That's just bonus of, having a cat. If I asked a student if they had a cat, having a dog had no bearing on whether they said yes to having a cat. That's the independent nature of it. All right. I'm going to have, let's see, how many more do you have? 1, 2, 3, 4, 5, 6, 7, 15. All right. So we're going to do for homework. Someone said 10. Someone said 20. All right, I'm gonna have you do the next 5 for homework. I think there's 15 total. After this question. About 15 total. So we've already done this one.
Okay,
so the next 5 after this.
Yeah. Okay, I think I did all of them.
Just a second.
That's 2.
Yeah,
That's why I was saying T had no bearing on that.
I know, but I didn't understand what you were saying.